Hello and welcome to today's class. So today we are handling the Schmidt process, and some authors call it the Schmidt autonomalization process, so it's basically the same thing. We have a question here, and the question is convert. We have a set of vectors here. It has 3 vectors into an orthonormal set, into an orthonormal basis. So the first thing is we're going to say that S, so our S is equals to 1, 1, 1, negative 1, 1, 0, and 1, 2, 1. So this one is equivalent to, so we have U1, U2, U3. So this is U1 here, we have U2 and U3. So fast forward, we find V1, and the formula for finding V1 is U1 so here we have 1, 1, 1 over, we find the norm of that vector, so that is basically going to give us a third. You can check our previous videos on how to get norm, a third, a third, a third. So that's our V1. Next we are going to find V2. The secret I give my students is that you must know the formula. If you know the formula, then everything else just follows. So, and the moment you know how to get the numerator, the denominator is always the norm of the numerator. U2 V1 V1. So our first step here is to find the inner product of U2 V1. That's the inner product of U2 is negative 1, 1, 0. V1 is a third, root a third, root a third, root a third. 1 over root of a third. So here, if you get the inner product, it's going to be negative 1 over root 3 plus 1 over root 3 plus 0, which is basically 0. So if you multiply this part, so you're going to multiply the inner product of U2 V1 by V1. You're multiplying 0 by V1, which is basically 0. So, and you know we have a subtraction here, so we can just say U2 minus this will just give us U2, and U2 is negative 1, 1, 0. So to find V2, we're going to get negative 1, 1, 0 over the norm, which is root 2. So our V2 is negative 1 over root 2, 1 over root 2, 0. So we have found the first 2 vectors. So we're going to the third vector, which is 1, 2, 1. We want to find V3. So our V3 is U3 minus U3 V1 V1 minus U3 V2 V2, and the denominator is the norm of the numerator. So we just copy that here. So this is the norm. So we are starting with the first, the second, and then we have U3 V1 is equals to the U3 is 1 to 1 and V1 is 1 over root 3, 1 over root 3, 1 over root 3. You can always pause in to go back. So if you check well, you will multiply 1 by this, then plus, so you're going to get 4 over root 3. So next we have U3 V1 times V1. So you're multiplying 4 over root 3 by 1 over root 3, 1 over root 3, 1 over root 3. So this is going to give us 4 over 3, 4 over 3, 4 over 3. This one you're not adding. You need to get the difference. So we have found that first part. So you go to the second part. Second part is U3 V2. Our V2 is just here, it's not far. So this is our V2. And our U3 we have it, it's 1, 2, 1. So we have 1, 2, 1. Our V2 is negative 1 over root 2, 1 over root 2, 0, which gives us 1 over root 2. This one will give you negative 1 over root 2, this one will give you negative 2, positive 2 over, if you add you get 1. And now next we have U3 V2 where we are multiplying 1 over root 2 into V2, which is negative 1 over root 2, 1 over root 2, 0. It gives us negative a half, 0. So we have found, so we want to subtract, and now we want to subtract and get this. So you're going to get U3 minus, so we have U3 minus U3 V1 minus U3 V2. Now this gives us U3 is 1, 2, 1 minus 4 over 3, 4 over 3, 4 over 3 minus negative a half, 0. So this gives us 1 over 6 minus 2 over 6. You can always cross check. So our next part is to get the norm. This is the numerator. So we said the denominator is always the norm. So we are getting the norm, or if you like, the distance. So this will give us 1 over 36 plus 1 over 36 plus 4 over 36, which is simply 6. But everything is raised to power a half. This is 6 over 36. 6 over 36 is 1 over 6. Raised to power a half. This one is raised to power a half. So that is the same as root 6 over 6. So we're going to rewrite this. So this is the same as root 6 over 6. So, okay, let's start. This is the same as root 1 over 6. This is the same as root 6 over 6. Oh, we can say it the same as 1 over root 6. Either way, you choose. So our V3 will be equals to 1 over root 6 so we are dividing. We have 1 over 6, 1 over 6, negative 2 over 6. We are dividing by root 6 over 6. This becomes 1 over 6, 1 over 6, negative 2 over 6 times 6 over root 6, the reciprocal. So we have 1 over root 6, 1 over root 6, negative 2 over root 6. So that's our V3. And now we have an orthonormal basis. So our V1, V2, V3 is equals to, our V1 is 1 over root 3, 1 over root 3, again 1 over root 3. Our V2 is negative 1 over root 2, 1 over root 2, and 0. Our V3 is 1 over root 6, 1 over root 6, negative 2 over root 6. So that's our orthonormal basis. And that is what we call the Schmidt process. So that is it for today, and thank you for joining us. See you on the next. Bye.